Okay, hey girls. Happy Friday, I think. It's going to be Friday when you see this. Anyway, as I said, I've got some video notes for you to watch during this class and then some homework. So we're going to kind of jump right in. As we talked earlier, we will correct the homework that was due today. We will check that and talk about that next week on Tuesday. So let's just kind of jump right in. So we talked about last class was finding relative mins and maxes. So this class, we're going to talk about using that ability or that capability to in application problems. So we're actually going to do some pretty basic application problems just to kind of show you the functionality here, but these are not going to be super challenging. Then we're going to get to a little bit of exercise in starting to sketch some graphs using derivatives. But anyway, so let's just see. So first, in reading this first problem, we've got a company has a profit function of this. So here's our profit, where X number of units are sold. How many units should be sold to maximize the profit? So again, we want to find the maximum or a maximum value of this function. So thinking back to our last class, finding maximums using derivatives, we want to take the derivative, right? So first, let's take the derivative of our profit function, and we get negative 3x squared plus 36x minus 96. We take the derivative, we set it equal to 0. Again, we're trying to find increasing and decreasing intervals so we can find maxes and mins. To solve this, we want to factor it, so we can take out a negative 3, and we're left with x squared minus 12x plus 32. We factor that, and we get x minus 8 and x minus 4. Solving those, we get 8 and 4 as our numbers. So these are our possible values for min and max, right? So we've got 8 and a 4 now. So we know that if we have a min or a max, it will happen here, but we don't know which is a max or a min. So we want to find out, we want to determine increasing and decreasing on those intervals, right? And that will tell us which one of these x values or number of units will give us a maximum profit. So we choose a value in the first interval to plug in. Let's choose 0. If we plug in 0, again, plugging in 0 to our factored form gives us negative 8, a negative 4, gives us a negative number. So we know that our function is decreasing from infinity, negative infinity to 4. We choose a value between 4 and 8. I'll just choose 5. And we plug in and we get negative 3 and then a negative 3. Hang on, let me just choosing 5 and a positive 1. So we get a positive. So it's increasing from 4 to 8. Test our last interval. I'll choose 9 as a test value. So I plug it in, I get a 1 and a 9 minus 4 is 5. Multiply all that together. So it's decreasing. So here I know I'm increasing, and then, I'm sorry, increasing. I'm trying to do that highlighter. I'm increasing and then decreasing and then, I'm sorry. Sorry, girls, I'm kind of losing it here. I am decreasing, then increasing, then decreasing. So my max value is going to be at the 8, right? So I have a max at 8. So I don't really care about the 4 anymore because I'm looking for max profit. So I have the max at 8 units. X represents units. And I want to find the profit I'll make at 8 units. So again, I'm going to plug it into my original function, my original profit function. So I can find P sub 8. And if you plug that in, again, very carefully on your calculator, you will get 872. So I encourage you guys to try that on your calculator. Make sure you get that. But again, we found our critical numbers by taking the derivative, setting it equal to 0, testing out our intervals to find which one gives us a max. And we found that the 8 units, plug it into our original function to give us our profit. So that's one application of max and mins. Let's try another one. So here we have a bicycle company has the following cost and revenue equations. And where P represents the price of the bicycle. First, we want to find the number Q of the units that produces the maximum profit. So again, kind of a throwback to last semester, we're only given cost and revenue, but we need to find profit. So again, if I were in class, I would ask for a volunteer, but I'll remember profit equation is actually the revenue equation, how much money you bring in by selling something minus how much it costs you to make those products, right? So first, before we can find the maximum profit, we need to use these two equations to find our profit equation. So I'm going to come over here and I'm going to take the revenue equation, 90Q minus 0.02 Q squared minus our cost equation, which is 25Q plus 5,000. If I simplify this, collect like terms, I end up with a negative 0.02 Q squared. And then 90 minus 25Q is going to give me positive 65Q, and then minus 5,000. So that is my just simple profit equation. Okay, so I've used my cost and my revenue to get a profit equation. But now I want to find the number of units that produces the maximum profit. So using my profit equation, I want to take the derivative. So I'm finding the derivative of Q, which is going to give me negative 0.04 Q plus 65. Right? So that is the derivative of my profit equation. I set that equal to 0 and solve, and I get negative 0.04Q equals negative 65 divided by negative 0.04. And I get 1625. So the quantity that I need to sell to make my maximum profit, well, the only critical point, actually I'm kind of jumping the gun here. I found a critical point of 1625. Now, I would like to verify that that's going to be a max, right? Because we know it could be a max or a min. So I should put that on my number line and test it out. So if I want to choose a value less than 1625 for my derivative equation, I could choose 0, right? I can choose as far to the left as I need to. So I'm going to choose 0, so 0.04 times 0 plus 65. That is going to give me that's 0 plus 65, so I'm increasing there. And then if I choose, I'm just going to say 2,000 on this one. If I choose 2,000, I'm going to say negative 0.04 times 2,000 plus 65. Let's just verify here. So 0.04, I'm sorry, negative 0.04 times 2,000 is negative 80 plus 65. It's going to give me negative 15. So I've got it negative. So yes, I'm increasing and then decreasing. So 1625 is the maximum. So I want to sell 1,625 bikes to make the maximum profit. And to find out what that profit would be, again, I'm going to plug in 1625 into my original profit equation, which is what we calculated over here. So if I find P of 1625, again, I encourage you guys to plug that in on your calculator, verify you get what I do, but you should get $47,812.50. Okay, so again, just an example of how to use relative mins and maxes in application problems. Okay, so I've got a couple of those for you for your homework. Again, pretty straightforward. Polynomials, not anything really fancy. Okay. Okay, now the next thing I'm going to do, actually, the next thing we're going to do is kind of just a little exercise in graphing that is, to me, it's kind of like a good warm-up to sketching graphs of functions that we'll do next class. But here we're going to sketch a graph using only what we know about a derivative. Okay, so we're not even going to get the equation. We're just going to be told some information about a derivative, and we're going to use that to sketch a graph. Okay, so here we're told we want to sketch a graph that has the following criteria. So we know that the derivative at 1 and at 4 is equal to 0. So what's that tell us? That tells us that we have critical numbers at 1 and at 4, right? Then it tells us that the derivative is greater than 0, right, which is another word for positive, or another way to say positive, when x is greater than 1 or less than 4. So that tells us we've got a positive on that interval. Next piece tells us that the derivative is less than 0 when x is less than 1. So that gives us a negative over here. But also when x is greater than 4. So it gives us a negative over here. So now we can see we're decreasing, then increasing, then decreasing. So that tells us we have a min at 1, and we have a max at 4. And this also gives us more information that tells us f of 1 is actually negative 2, and f of 4 is 1. So if we wanted to sketch a graph of this function without really knowing too much about it, we can draw a graph. Again, we only need the points here that we know about. So we need 1, negative 2. We need 4, 1. And we can use our increasing and decreasing to connect the dots. So we know it's decreasing until it gets to 1, then it's increasing, then it's decreasing. So presto, we have a little graph. Again, we don't ever know the equation, but we can sketch the graph just using that information. Let's try another one. So again, we're not given an equation, but we're told that that the derivative is 0 at 2 and at negative 3. We're told that the derivative is less than 0 or negative between when x is greater than negative 3 and less than 2. So we know it's negative on those intervals. We know it's positive or greater than 0 when x is less than negative 3 and when x is greater than 2. We're also told the original function at -3 is 4, and at 2 is -2. So we can draw our graph. A couple of points here. We need point -3, 4. We need point 2, -2. And we can use our timeline up, or number line up here to connect the dots. So we know we are increasing till we get to -3, decreasing between -3 and 2, and increasing from 2 to infinity. Okay, kind of fun, maybe. I don't know if y'all think it's fun or not, but all right. And actually, I guess that's it. So anyway, kind of hopefully you feel like it's kind of a simple lesson today, not too much going on. Your homework is just a combination of sketching the graphs, so 3 sketching of graphs, and then 2 word problems where you're finding the max profit on both of those. So again, actually, it was a little bit too simple, but anyway, so hope you guys are having a good Friday, and you should have plenty of time to finish this homework. So then remain quiet and behave for your sub if you get done early. And I will see you guys I'll see you guys next week. Have a good weekend.